General flowchart. First, start. Then, read and analyze the function. Then, find the restrictions on the domain. Then, find x and y-intercept coordinates. Then, find symmetry, horizontal and vertical asymptotes and gaps. Then, find the first derivative. Then, do the ID quest. Then, find the second derivative. Then, do the concavity test. Are all the values correct? If no, read and analyze the function again. If yes, grab the function and decide range. Then, grab the function with the first and second derivative in the plane. Then, review answers and graphs, and then end. These are the critical point and inflection point flowcharts. To the critical point, you must start, then obtain your critical point and analyze your function. Then, get the first derivative, and then you must equalize your derivative to 0. Then, you end. To obtain the inflection point, you must start, then analyze the function, then get the first derivative, then get the second derivative, and then equalize your second derivative to 0.
First, we have to get the domain of our function with limits, with the limit of x when it approaches infinity. Our function is x to the fourth minus 4x. Then, we continue with limits when the limit of x approaching to infinite. We substitute the values with infinite, so it's infinite to the fourth minus 4 times infinite. Then, we do all the operation that ends with infinite minus infinite, that is equal to infinite. That gives us the domain, that is, x belongs to all the real numbers. Our function is f of x equals to x to the 4 minus 4x. And we have to find the x and the y-intercept. First, the x-intercept. We have to all the function make it equal to 0. In order, we can isolate all the functions and the variables. We do by common factor, that is x, and we get x times x to the 3 minus 4. And first, we have our first value of x, that is 0. And our second value of x, that is x to the x cubic minus 4. And we have to isolate that. That gives us x equals to cubic root of 4. Then we have to find our y-intercept. Here's our y-intercept. And we have to make all our variables 0. So we have our function x to the 4 minus 4x, and it is 0 to the 4th minus 4 times 0, which is 0, and gives us that y is equal to 0. And that is our y-intercept.
To find the symmetry, we have to analyze our function and check if f of minus x is equal to f of x to see if it is even, or if f of minus x is equal to minus f of x. We first substitute minus x in our function, and we get that is x to the fourth plus 4x, and that is not equal to f of x, so our function is not symmetric to the y-axis. And since it's not minus f of x either, then we get that our function is not symmetric to the origin. So we have that our function is not symmetric.
To find if our functions have any vertical asymptotes or horizontal asymptotes, since we know that our function is a polynomial function and that polynomial functions do not have any restrictions, then we know that our function does not have neither a horizontal asymptote or a vertical asymptote.
You have the first derivative, that is f of x equal x to the 4th minus 4x. Then you derivate, and that's your answer. To obtain the critical point, we equal the first derivative to 0, and then we have to solve it. Your answer is 1. Then we substitute the x value in the original function and then solve it. Your answer is minus 3.
Now we use this value we chose that are not the ones of the critical point to see the function's behavior at those points.
The second derivative, you must use the first derivative that you already derived and then solve. That's your answer. To obtain concavity, you must equal the second derivative to 0. From minus infinity to infinity, function has positive concavity. This function do not have inflection point. This is the graph of the main function, and this is the domain, and this is the range. This is the graph with the main, the first derivative function, and the second derivative function.